I didn't follow the rules, and I didn't put my presentation in the official template. So let's make that a little bit of a theme here. Let's not follow all the conventional rules, right? I think between Thomas and those of you who are in Max's presentation and Oscar's presentation here are noticing a developing theme around the new IT, the new style of doing the kind of work that we all do. We're starting to disrupt a lot of the traditional ways of doing things, a lot of the traditional apple carts. So before I get into the meat of the presentation, let me tell you a little bit about myself. I lead up an area for Accenture called Lightweight Architectures, which makes sense. You know, you get the biggest person you possibly can to lead up something called Lightweight. I've spent most of my career in the startup space, then came to one of the largest technology companies in the world, because that's a logical step, right? And also spent some time teaching in university and a couple other things. And have kind of a weird background in addition to computer science and software engineering and stuff like that. So, like I said there, like I say in the slide here, if you want to know about obscure facts in ancient history, I'm also your guy. I'm really good at bar trivia, except for the sports stuff. So let's set the stage here, and I'm going to spend most of the time up here talking about technology and architectures, but let's repeat a lot of the stuff that Max said in the session in the pink room. The new style of IT is the new normal. Mark Andreessen, who if you remember the good old days of Netscape, was one of the founders of Netscape, created some of the early web technologies, now runs one of the largest VC firms in Silicon Valley, has a great term that I steal from him all the time, which is software is eating the world, right? Businesses, when I used to talk about this stuff 2 or 3 years ago, at a lot of Accenture's clients, I had a lot of people always would sort of get this smug look on their face, and they'd say, well, we're not a technology company, we're a hospitality company, or we're a manufacturing company. We don't do this fancy stuff, right? Nobody is saying that now. Because I think everyone gets and is being moved into a place where we're all technology companies. We're all competing with software, right? Software is the channel through which we do customer engagement, and that our products are beginning to be eaten by software as well. 5, 6 years ago, how many of us would have thought that one of the most talked about car companies would be a company that focuses primarily on the experience inside of the cabin, right? Having a gigantic tablet instead of traditional knobs and buttons and things like that. I think with the Model 3 unveiling, Tesla has surpassed something like 300,000 pre-orders already, which would make them, if they actually fulfill all of those pre-orders, would make them the 3rd largest car company in the world by the time they fulfill said pre-orders, right? When they actually get to manufacturing that. We'll talk through a number of things here. I want to leave you with, if you take nothing else though, I want to leave you with a couple of big points, which is that in order to fundamentally survive the next 5 to 10 years in industry, all of us are going to have to become digital natives, right? That's not just for the Amazons and the Apogees and Dockers of the world, right? It's for all of us. We're all software companies. In order to do that, we're probably not going to see budgets increase to reflect the new cachet that software has. We're going to have to do a lot more with the same amount or slightly less money. And we're really going to have to embrace very fast delivery speed, a different approach to how we do a lot of this stuff. So I'm not going to focus on that aspect here. I'm going to focus a lot more on the actual architectures that make this stuff happen. So just a couple of examples real quick. 3 or 4 years, and I do a lot of work in the hospitality space right now, so a lot of my examples will sort of follow this theme. So 3 or 4 years ago, almost everyone in the hotel space was sort of kind of laughing at what Airbnb was doing, right? Oh, they're renting out the third room in somebody's house. That's funny and cute, but it's not going to disrupt the corporate travel space. It's not going to disrupt the traditional hotel space. Once again, nobody is laughing now, right? It hasn't necessarily eaten into the core revenue space yet, but a lot of the traditional companies are watching their margin disappear as folks move towards some of the new lodging companies like Airbnb, fundamentally speaking, I think even I was actually surprised myself at how quickly this happened, but they're moving into the higher end experience and travel space faster than anyone thought they would, right? And Uber has put I didn't actually tried to get an Uber in Helsinki, and it took a little while. I'm used to using it everywhere, but I think a lot of you see in Paris where the taxi unions are overturning Uber cars and stuff like that because you're watching a traditional industry in its death throes. Right? The taxi industry will not be here in its current form once legislation catches up to the business reality of the situation, right? And these companies are they're not powered by ESBs and WebSphere, right? They're powered by a fundamentally different category of architectures. They're rethinking how a lot of this stuff is done. So how are we as folks who do software for a living, but either work with fairly traditional business clients or work inside of fairly traditional businesses, the banks, insurance companies, and hospitality companies of the world. How are we going to adapt to the new normal? And I think that's fundamentally three things that we have to think about, practically speaking, right, in terms of delivery. Embracing new delivery methods, embracing DevOps and automation, and embracing lightweight architectures. And I think often enough, and you see really big focus on the first two areas. I think everyone realizes that they need to become more agile and that the way that they deliver work needs to change. And everyone realizes that they need to automate more, they need to remove some of the manual processes. But you still see a lot of folks think that they can do a lot of those things with very traditional technologies and architectures. And that's, so my proposition to you all is that, my proposition to you all is that that's not possible. Or at the very least, that the returns that you're trying to get from embracing those things will be far less if you try to, hook that big anchor to your speedboat, right? The cruise ship anchor probably doesn't belong behind the speedboat if you want to go really fast. So there are many folks that focus on the new delivery method side of things and the DevOps side of things, but since we're at TechArch Day, let's focus on the technology architecture piece. So what is a lightweight architecture? What the hell does that even mean, right? Is it just yet another fancy marketing term? So I tend to think of it in a couple of different areas, right? A couple of different features of what makes up a lighter weight architecture. So the first thing that's not on here, because I think it's blindingly obvious, is that it really is lighter weight. The size of the applications and platforms that we're delivering, that we're building, tend to be a lot smaller, right? If you try to take a lot of the examples around deploying applications, deploying with Docker, moving very quickly, if you try to do that with WebSphere, good luck. Right? You're talking about an application server that by itself is 5 gigabytes. Right? So just containerizing that presents a whole set of problems that if you're using Tomcat or Netty or let alone Node.js, that you don't have. Right? Tomcat is 200 KB. Right? So we're talking about something that's fundamentally a lot smaller. We've moved from monolithic to very modular style. And when you see Thomas's presentation, the large boxes are replaced by small boxes, right? A lot of the applications that we're building, we're not building applications of any lower complexity necessarily, but we're splitting up that complexity in such a way that we deal with it piece by piece as opposed to dealing with it all at once, which is one of the ways we can actually get to many, many deployments a day, or working and speeding up cycle time very fast, is that we deal with smaller increments and we can release smaller increments. We're moving toward more ubiquitous technologies in the UI side of things. Though we will still write an iOS or iPhone-specific application or an Android-specific application, we're trying to reuse as much of the platform code as we possibly can and just save the device-specific stuff for where it counts and where it can help make it feel like a more native experience. Right? What we were doing 3 or 4 years ago, which is writing basically completely separate applications for our different channels, that's cost prohibitive, right? So we're trying to take a more universal approach and build modules that can be reused on many different platforms. I think a lot of us, how many of you work exclusively in one technology stack? So are you a Java architect or a .NET architect or a Ruby on Rails person or something like that, right? How many people still do that? I see no hands, which is good, right? I see a lot of, and I'll steal my own thunder for later in the presentation, but if you tell me I'm a J2EE architect, that's a really good way of telling me don't hire me, right? So we're moving toward using the best tool for the job, using a sort of a polyglot style. We're moving from tool-based integration, so let's slap MuleSoft in place and everything will just fall into place like magic, to going toward a more API, standards-based style of integration, and making common contracts between modules and that sort of thing. We're moving from a very vendor-driven architecture to where we choose a bunch of packages, usually with one logo on them, toward embracing a big open source ecosystem, which, since Finland is one of the leaders or one of the early leaders and pioneers in that space, you guys are much easier to convince than others of that, right? So, and then of course we're moving from features being released in months to features being released in days, right? Or several times a day, as the case may be. And releasing features in a very quick time frame is a hell of a lot easier when you don't have to regression test an entire system to be sure that changing a button color is not going to bring down the entire application. Right? If you can be sure that what your change is isolated to a particular module or to a particular piece of that application, all of the process stuff around that becomes a lot easier, right? So we have a traditional architecture here, right? Lots of big blobs. Each time we want to change the booking experience for a hotel, we would have to change some integration, we'd have to change some things on a mainframe application, and we would have to go change a bunch of stuff in a web app, and then we would go, test that whole stack all the way down, release once every quarter, and the business never actually gets what they want, so every new piece of software is a really good opportunity to just pile on with a bunch of requirements and only still get half of what you want anyway, right? So if we transform to what we're emerging to, and what in many cases folks are already embracing, we have much smaller increments, much smaller pieces. Our back end is starting to be broken up. What used to be a mainframe, and this is a real example, by the way. This is one of my current clients. We're breaking up what are in many cases 30 or 40-year-old systems. And to complicate that, they're not only 30 or 40-year-old systems, they've been continuously developed for the past 30 years. Right? So when we're talking about a reservation system based on Sabre, sitting in most of its business logic is in COBOL, and the folks that wrote it originally are no longer even with us in a quite literal sense. We suddenly have a little bit of an issue there. So breaking that up, bringing it into these smaller, more bite-sized pieces is also a survival strategy, right? So we tend to think of things in terms of microservices, and I hate that we've started to overuse that word because it's starting to become what SOA promised to be, but ultimately failed to be, because as we all know, SOA became a really good way to sell an ESB and not a good way to actually create a service-oriented architecture, right? So now we get a chance to redo that. So let's redo that and not use the terms incorrectly. Sometimes being pedantic is a good thing. But in terms of being able to break out these pieces of functionality, it's a lot easier for me to to respond to customer feedback on your booking experience on your website is too complex and we're getting lots of calls, what have you. It's a lot easier for me to change that experience if I can change one value in an API and then change the UI and then it suddenly works and I can fix that in a week. Right? Rather than, okay, I have to change 75 different things on each one of these areas, and oh my God, I have to look at COBOL code, and I wasn't even born when this code was written, right? So the Sherlock Holmes hats don't have to come on, and we can all, not be detectives and be developers, right? So, as I said before, I think the benefits of new IT are going to be incompletely realized if we don't make fundamental changes in how we do technology architecture. And all of the process changes and all of the training and all of the experience in the world is not going to make up for the fact that we have inferior equipment, if indeed we have inferior equipment, right? The Spartans lose against the people that are trained which end of the rifle goes toward the enemy. In a week or so time, they always lose, right? People that are trained for an entire lifetime of doing what they do, if they have inferior tools, they're going to have a really hard time actually achieving their objectives, right? And if we as architects and engineers have not only an inferior set of tools, but we're thinking of things in the wrong patterns and in the wrong way to actually build these things, we're going to have a much harder time. So even with a lot of the modern methods, with a lot of automation tools, if we don't make the architecture investments, we're going to have a hard time as well, which in traditional businesses is not the easiest thing in the world to do, right? So there's various methodological things that we can do and ways that we can isolate change and things like that, which we could easily spend 5 or 6 hours talking about here. So why do we need lightweight architectures, right? Why do we need to start recomposing and rebuilding some of these systems, or at the very least, as we build new systems, build them in a different way? Because we're really solving a lot of business problems, right? Or at least very costly impediments to actually getting technology delivered, right? I think everybody remembers the old project management adage of, 100% of projects are over budget. 50% didn't meet their basic requirements, et cetera, et cetera. I think in many cases, in a lot of fairly traditional industries, things are even worse than that, right? And oftentimes the business will go to an agency or they'll go to a third party to go build a new application because they know that they can't get that application built if they go the traditional route and go through traditional IT, right? Which then, when that application comes back, IT is expected to maintain it, right? So, if we solve a lot of these problems, we as technologists are engaging not only in doing the right thing, in making sure that our businesses survive, but we're also engaging in getting a seat at the table to help make strategic decisions. So, we're solving the problems like test and integration complexity by modularizing things, making standard contracts between those modules, slow feature releases by having separate deployable entities, separate deployable applications that ultimately make up a seamless whole. So scalability, right? The ability to very effortlessly and quickly scale without thinking about it or without spending a lot of times debating silly things like which database, which relational database has the best clustering capability. The answer is none of them, right? They're all terrible at that because they were never designed to do it. The ability to protect from failure and spend lots and lots of time. I'm just playing into the Couchbase guys. I'm not a paid marketer for those guys, but Got to afford my new house somehow. So, we spent lots of time in traditional system architectures figuring out how to protect every little component from failing, right? So we'd have all of this crazy stuff, and I could go off on a huge tangent about security where we do this too, where we build security theater architecture as opposed to actual security architecture. That if we just did things right the first time and checked it and built security into the process, we wouldn't have to have web application firewalls that destroy the performance of our applications ruthlessly. But in terms of failure protection, we have the same thing, right? We bought load balancing appliances. We bought lots of really expensive monitoring tools, and ultimately, bought into some of the marketing hype of applications that were never really designed to be living services that just don't go down. And of course, we have technology that limits user experience as well, right? Where if you're trying to build a very traditional web application, if you're not using JavaScript on the front end and building building applications where it's largely sort of client server for the modern day, and you get it feels like a mobile application even though you're through a browser, it doesn't matter how good of a developer you are. The expectation that your users have is that when they click on something, they're going to get an immediate response, right? So even if it only takes 500 milliseconds, it's still jarring, and it still disrupts the experience because the expectation has changed. So let's talk about some of the solutions to these things. We have monolithic systems that we've built traditionally. So we can use patterns like microservices, modular user interfaces to ultimately break that up and build something that is sort of bite-sized and the right scale for the right problem. There. That's the only animation that I included in the presentation, and it managed to trip me up. So we have microservices architecture, fundamentally not that much different from what we ought to be doing in the first place, which is we group the like-for-like functionality. We have data or databases that are specific to the application context, an application server or application environment that's embedded within our deployable entity, and then some application code on top of that, right? And we can use different languages and different technologies to do things that they're good at and solve business problems that they're good at, rather than trying to do everything with one thing. If I have one objection against folks that really try to standardize on things, it's that. I'll save that for a minute because I have a good visual for it. But we can break these things up. We can modularize, and ultimately get a lot of benefit along with that. And the corollary to what I said earlier is also true, right? If you don't have DevOps, if you don't have automation, if you haven't changed the delivery process, you're not going to get much benefit out of this either, right? Because if you don't have all that automation, if you don't have a deployment capability where you can push these services out into the wild, what have we done by doing something like microservices? Well, we've just taken the number of deployable applications from 50 to 500, right? So if deployment and testing and things like that aren't really, really cheap or completely automated, then we're going to have an even harder time than we did before, right? So all of this is very complementary. So if we have very slow feature releases, part of that is in the deployment process. I'm not going to drain this one because if you didn't see Oscar's presentation, watch the video. It's really good. Scalability is something that in traditional architectures is something that's very difficult to do, right? Because ultimately we're following a thread-based model, right? There's this great analogy that was thrown out there in the early days of Node.js and Twisted and some of the early reactor pattern-based application architectures to try to explain what us eggheads were talking about in terms of functional architectures or distributed architectures, right? Which is the parable of the doctor's office. Right? If we, in a traditional threaded context, if you were to walk up to the receptionist and she hands you the forms, and you sit there and you stand in front of the receptionist and block anybody else from coming up there and fill out your forms, the only way to scale is to add more receptionists, right? But if you go up, grab your forms, go sit down, they can serve the next person. When you're finished, you walk back up, you hand in your forms, and then you go do the next thing. One concurrently operating receptionist can handle hundreds, if not thousands, of potential patients, right? So thinking about things in that very concurrent way, or thinking about things in having multiple actors that can do the same thing, right? So multiple concurrent systems, and achieving actual parallelism, we can start to think of some of the patterns through which we can build really, really highly scalable systems really, really cheaply, right? We can vertically, if we get rid of application state in many cases, if we use some of these patterns that Node.js or Spring's Reactor project or Scala or many, many other technologies, what we were doing back in the day with Python and Twisted and Event Machine and Ruby, or libevent in C, right? Every language has this capability now. We can use fairly limited hardware resources, which there's no such thing as limited hardware resources. Talk to the AWS folks. Hardware or compute power is approaching zero in terms of cost, right? So one CPU basically costs nothing to deploy onto, but if we want to think of a problem of serving millions upon millions of users, or just having a system that's very resilient and redundant, having any node able to replace another node without any additional work is actually a really valuable thing, right? So using things like the reactor pattern, the actor model, proactor, there's a couple of other patterns that do this. Reactor is probably the most common. So if you have it's ultimately very simple, right? You have the event dispatcher, which is your receptionist in our earlier example. You have event handlers, and you have events coming in and being routed out to where they belong, right? So when you come in to fill out forms, you go sit down and fill out forms. When you're ready to go into the doctor, you go in to see the doctor, right? Those are separate events. If we process those through a very simple event handling mechanism, and focus on things like routing and network I/O, right? We get systems like Node.js, which even though it's single-threaded, even though the JavaScript is nowhere near as high-performing as Java and the JVM, Node.js-based systems tend to massively outperform traditional systems at scale, right? And they do that through clever use of these patterns. So in terms of reliability, it's really nice when we have patterns that allow us to swarm the problem, right? If how many folks use Netflix? There you go. So how many times have you gotten an error message from Netflix that says your video is unavailable or something like that? I think all of us have gotten that, right? How many times do you just go ahead and press play again and it works? There you go. So you don't often get that error message again, because if there's an error that happens in the environment, the node that was offending is taken out of rotation. It goes through a series of health check processes. If it fails, they just blow it away and create a new node. Right? Very cheap deployment, very cheap way of adding additional horsepower. But they do that through this mechanism of the circuit breaker, right? Where if something is not working, just take it out of rotation so that it doesn't end up, serving a bad experience to multiple people. Because if we use traditional load balancing methods, if you have four nodes and one of them goes bad, your load balancer is going to send 25% of your traffic to a bad node, right? So you have to invest lots and lots of money in making sure that none of those nodes ever fail. Lots of redundancy issues, right? But if we follow a simple rule of if something fails, take it out of rotation so that it doesn't ruin the experience for any more than one person, the vast majority of our users are far more satisfied, right? And making sure that we can take things like application state, throw them to the side, handle them in different ways, right? most of the metadata that you use and keep track of in state can be handled in HTTP headers or security tokens or other mechanisms where you can keep track of transaction integrity without necessarily binding you to a single server and a single thread on an application. So if you if you use those methods, we can actually have one node replace another node, right? It will be very simple to follow that kind of circuit breaker pattern. So if you look at traditional user interface technology, right? And this is something that I think we're all starting to use Angular or various JavaScript frameworks to build UI these days. I was actually with a client not too long ago, and he was telling me that we're looking at what investments to make in the user interface space. And I see that server-side rendering is coming back, right? People are starting to do more rendering on the server side. And I said, that's an interesting statement, right? Let's unpack that a little bit. What do you mean? And then we quickly came to realize, and I think he got a little embarrassed, that industry no longer means what he thinks it means by using the term server-side rendering. We've come so far from JSPs and even traditional Rails or PHP or what have you, that server-side rendering now means pre-chewing your JavaScript application on the server and sending down a consistent, already rendered application, right? So we're pre-rendering something on the server so that we can have consistent delivery speeds, right? But there's no suggestion that we move away from doing most of the UI processing on the client, because the fastest place to get feedback is, right here. So this move, or not really move because we've completed it, but this transition back to what I like to call client API. You see client cloud floating around. It's really just client server all over again, right? But because the best place to do simple UI transformations is right on the client. So moving toward that kind of use case, or moving toward that kind of rendering technology, what have you, is a really interesting way to give the user experience folks what they want as well. They get a lot more control and a lot more capability. There was very limited, designers felt very disempowered, and still do in many folks who haven't moved in this direction yet, but very disempowered by the capability that they actually have to create new and interesting and simple user experiences on something where you have to make 1,000 round-trip connections that the client sees every single time when you have to reload the page, right? So a lot of the UI technologies that have been gaining prominence in the last couple of years, the Reacts and Fluxes of the world, are making it much easier for designers to do their jobs and much easier for developers. So many more problems solved by these patterns, by other patterns, right? So we, like I said, we could spend hours talking about them, but let's get into a couple of the implications, and then I have some statements where we can ruffle some feathers and see if we can generate some good questions. So what are the implications? And that is, we're changing from having very large, expansive teams that don't specialize a whole lot and don't, one person has one or two skills, back to software engineering as an art form, right? It never really stopped being an art form. We just stopped treating it that way, and then our applications turned to shit. So we're coming back and thinking of things in this way. And the reason we're doing that is because as you're going to get tired of hearing by the end of the day, that software architecture is now critical to business strategy, right? If all of our communications with our customers, if all of the ways that you interact with the product are now digital experiences, you better be damn sure that digital experience is going to work, and it's going to delight customers, and it's going to differentiate you from your competition. So let's make some fun statements in the last couple minutes here. So my first statement as we design new architectures is that ESBs must die in a fire. if you create a single point of failure in a brand new application architecture, and this is not to say, right, that in legacy integration scenarios that it's not still a valuable pattern, right? It is. But if you're building brand new systems, if you're trying to build web scale systems, I hate that word, but let's use it, creating a single point of failure that sits inside of a data center, probably not a great idea. I think it's actually very telling that if you look at the different things that AWS has come out with over the last 2 years, an integration bus is not one of them, right? Because nobody actually wants them in cloud scale applications because they don't work to actually do what you want them to do. So, do you guys have sporks here? Did we inflict that awful design thing on the Nordic countries? Now, so in American fast food restaurants, you can get these things that don't work as a spoon. They don't particularly work as a fork. So you basically just eat the food with your hands. A lot of traditional technologies, the Javas and .NETs of the world, are always build themselves as not being specialized, right? And the result is that in modern, more complex system architectures, they're not actually particularly good at anything, right? Which is not to say that we're not going to continue to use them. We are. There are some things that they're very good at. Let's use them for those things, and use other technologies and other architectures for other things, right? Let's use the best tool for the job, and let the automated deployment processes and all that take care of the varied different runtimes that we're using. If you're trying to build a system that handles parallelism really well and does sort of real-time on-the-fly analytics, tying that to a thread-based model is a really good way to go back to batch processing, right? If you're able to actually handle parallel processing, you're going to have a much better time. And I see this quite a bit in my role of doing a lot of sort of architecture QA work. If I see a bunch of package logos with no understanding of how everything fits together, it's a really good way to say that we're just making software companies money without actually building an application that's going to suit the needs of the user, right? Yes, we should absolutely make sure that we use the right vendor products. No, we should not just assemble a bunch of alphabet soup and cute logos and then assume that we're going to have a working application architecture. And the last thing is queues are now completely useless. We have concurrency. Don't use them anymore. Every time I hear the words, I put this queue in place for performance reasons, the gods strangle a kitten. So we like kittens, so don't use queues. So that's it. And now I think we've got some time for questions.
Yes, thank you, Matt. I'm a developer, and you truly spoke to my heart. But let's have that 5 to 6 hours conversation you were referring to now in these 10 minutes. I suppose we have lots of questions about how to go there, actually. Mm-hmm. Okay, so who has the first question to ask? I see lots of silence. Oh, there's the...
Hi, do you have any best practices how to embed master data management and master data into the microservices?
I do. It's a long and storied answer, but suffice to say that if we don't think about the data problem, if we don't think about data replication, if we don't think about getting stale transactions and keeping good integrity and things like that, we're never going to get to the promised land of milk and honey, right? So I see a lot of folks will throw out the words microservices and things like this, and then they're like, oh, but by the way, we're just going to we're going to use MongoDB or something like that, and that's going to be our sole database, or Cassandra or something, or what have you. And it's like, okay, I like NoSQL technologies as much as the next guy, but what about transaction integrity, right? Have we thought through the data implications of the system that we're building? So the words, use the right tool for the job are there for a reason, right? That applies to databases just as well as it applies to anything else. And making sure that we have things like consistent test data and consistent data across environments and things like that becomes an even more important function than it is today. So I kind of dodged your question, but by saying a bunch of extra stuff. But suffice to say, it's like I said, we could have a whole hour session on just that.
And we are having one session on data here on the green track later this afternoon. It's Dominic Wagenet talking about that.
Yeah, and Dominic is one of my colleagues, and he knows way more about that stuff than I do. So if he doesn't answer your question, then no one can.
Thanks. Other questions? Now you have 5 minutes more time for the 6 hours. Okay, so then I'll go with mine. Well, you kind of broke my heart too, since everybody's talking about Docker and the how to fit how to do the containers. But how do you, since I'm developing on JBoss, is it like no way for me ever, since I'm not on Node.js?
So I like to call JBoss if you want a really big application server that has all of the problems that WebSphere and WebLogic have, but you want it to be open source, JBoss is your system. I now live in Raleigh next to my colleagues at Red Hat, and I love those guys, and they do a lot of good stuff. I always make fun of them about that. But so if we take a step back for a second, and the core of JBoss is just Netty, right? It's just a simple stripped down application server. The question that I would ask is, do you really need all of the stuff that JBoss has? Or can we start advocating for using a lighter weight application container with the same system and cutting the complexity of that system to the point where we can use Docker and can get everything that we want out of it?
Okay, very good. That is for you architects to figure out then. Okay. Any new questions popping into mind?
I spent a good portion of my career as a teaching university on and off, so I noticed that nobody was in the front row here. It's
yes. Well, what about the COBOL code that I just saw yesterday and was figuring out with my team how do we do the modifications to these 20,000 lines? Do you have any ideas on that front? How we go from these systems to the lighter weight architectures?
Yeah, I think there's a couple of ways to do that, right? One is there are really good, and a plug for another one of my colleagues, Accenture has a really good practice that does this. There are ways to do code generation and sort of rapid application migration in such a way that you don't end up getting JOBOL or some other nonsense that looks like COBOL but doesn't actually do what you want it to do, and can migrate the application fairly quickly to at least an architecture from 10 years ago as opposed to one from 40. So that we can start to do some of these things with it. The other way to approach that problem is to sidestep it, right? So if we want to serve up new customers on different platforms, there's nothing that says that we can't do the same thing that the mainframe does sort of to the side and just sync up the data with the mainframe as the master record, right? So, build a set of microservices that go do the same activity and perform the same functions, and then send their write activity back to the mainframe system. Because if you look at read-write ratios, it's usually at least 10 to 1, if not more. So if you can save a lot of that activity, you end up saving a lot of money, as well as making sure developers don't go bald or have gray hair early.
Okay, very nice. Hey, thank you a lot, Matt.